Hi friends, today we are going to discuss about how to study PP2. Especially we are going through different course dispersion like suspension, emulsion like that. Today we are focusing on flocculated suspension. Let me discuss deeply on if you get a question like this formulation of flocculated suspension. So, whatever be the question of physical pharmaceutics too, you're supposed to write a proper definition. If any diagrams are there, you're supposed to write. So, hope you know, right? What do you mean by suspension? Suspension is a coarse dispersion in which insoluble solids are suspended in a liquid medium. So, what is the difference between flocculated suspension and deflocculated suspension? So, our question is about how to formulate a flocculated. So, first you are supposed to write what is suspension, then you are supposed to write flocculated suspension. So, flocculated means some aggregate or agglomerates are there by the chances or by the course of chemical bridging. So, what happens is that aggregate we are calling it as flocs. So that flock means light fluffy agglomerate that is occur by chemical bridging, and that is due to the weak van der Waals force of attraction. So let us think about what are the features of a flocculated suspension. Means how we can find whether it is a flocculated or deflocculated suspension. So flocculation means we already said it is an aggregate, right? So if it is a flocculated suspension, we can see a clear supernatant layer. Supernatant means upper layer, and we can see loose aggregate, and that case the rate of sedimentation is high as well as the particles settle as flocks. And in this type of flocculated suspension, it will not form a hard cake and it is easy to redisperse the sediment. And if you tell about or if you are plotting the potential energy curve, the flocculated suspension represents secondary minimum, and this flocculated suspension, when we are telling about the bioavailability, is having comparatively less bioavailability. Okay, so this is a thing that is relating to van der Waals force of attraction. So here, if PRT plotting is there, in the y-axis we are plotting the energy of interaction, and here we are thinking about the distance between the particle. So as we know, the particle-particle interaction influenced by so many factors like ionic strength, pH, size, and valency of added electrolyte. So the energy of attraction we can see in positive as well as negative side. So if we are keeping a particle like this, it can undergo two types of curve, either a repulsion curve or attraction curve, and this is the region of deflocculated state, and this is the region of flocculated state. So that's why we said the region of flocculated state we are calling it a secondary minimum, and region of deflocculated state we are calling it as primary minimum. So this plot you are supposed to draw if you are telling about DLVO theory or suspension of flocculated suspension. So the next thing is that whatever it is the formulation of suspension, the particle, if we are adding a wetting agent and dispersion medium, it will result in the formation of a uniform formulation or uniform dispersion of the deflocculated particle. So these are the three approaches we can see in the formulation of suspension. The first thing is that if you are adding a or incorporating a structured vehicle, it will result in deflocculated suspension. Apart from that is a one case. Second thing is our question. If we are adding a flocculating agent, we are getting the flocculated suspension as final product. And C means that is a combination of this A and B. That is, first of all, we are adding a flocculating agent, then we will get a flocculated suspension. Then we are supposed to add an incorporation of the structure vehicle. We will get the flocculated suspension in the structured vehicle as final product. So these are the various formulation aspect of suspension. Next thing we are thinking how we can make a control flocculation or flocculated suspension. So various ways are there by adding various flocculation agent. So flocculation agent we are categorizing as example as electrolyte, surfactant and polymers. So for this making the control flocculation, different approaches are there. First approach is like that we are adding a dispersed particle, and this dispersed particle is having surface charge and because of that theta potential decreases. That is one case. Second approach is that instead of this surface charge particle, we can add surfactant and polymers. So what the surfactant polymers will do is that they will act by absorbing a part of the long chain compound and they will form a flux. So these are the two different approaches for formulating a controlled flocculation. So this is a typical relationship showing this is a caking zone, this is a non-caking zone, again going to the caking zone. So this is a suspension example. So what we are doing is that we are telling a formulation. We are calling bismuth ion. That bismuth ion is having positive charge, we know, right? So we are adding the flocculating agent or negatively charged phosphate ion. So what happens is that if you are plotting the apparent zeta potential and we are adding our potassium hydrogen phosphate, which is a flocculating agent or negatively charged ion, based on that we are getting this song. So we said flocculating agent are of three types. So first we think about the first of our electrolyte. So what we are taking is that today when we are dispersing bismuth subnitrate be our reagent. So if we are dispersing our bismuth subnitrate in water, bismuth is having large positive charge or zeta potential. So what happens is that the system become deflocculated. So to this is bismuth subnitrate, we are adding a flocculating agent. Let it be monobasic potassium phosphate. This is a negatively charged particle. So what happens? This will get absorbed, right? Positive charged bismuth particle will deposit on the monobasic potassium phosphate and the solid begins to form flocks. If you are again adding electrolyte, what happens? It will go to the deflocculation state. That's why we see the last diagram as caking, non-caking, again caking. Means if you are adding more amount of electrolyte, it will go back to the deflocculated state, but it is going to the negative. Next thing is that this is the thing. This is another representation means we are adding an uncoated deflocculated particle. Negative charge is the as we said. So what happened? This bismuth positive negative will come and it will form the coated particle and we are getting the. So next thing is that next example of flocculating agent is surfactant. So surfactant, what is the action? They will reduce the surface tension and the surfactant will act as wetting as well as deflocculating agent. So this is a surfactant. So hope you know surfactant is having a positive head as well as tail part. So this positive head will caught on this sulfate like this tail part. So this is a diagram showing the flux formed by the surfactant, let it be lauryl sulfate. So what happens? This will reduce the surface tension and will act as a wetting and deflocculating agent. So examples are SLS or sodium dioptile sulfosuccinate. And third example for flocculating agent is polymers. So the polymers also act as flocculating agent. So what happens is that the polymer chain get absorbed on the particle surface and it will project out into the dispersion medium. So these are the various flocculating agents. So this is the next diagram showing the sequence of events involved in the formation of a stable suspension. So if you are adding a cationic adsorbent, let it be like this. Then if you are adding an anionic flocculant, let it be like a coated particle, then we will get a flocculated particle. And finally we are getting a suspension of flocculated suspension like this. So if we are adding a suspending agent, finally we will get a finished suspension. So these are the things we are supposed to write if you are getting how to formulate a flocculated suspension. Hope this video will be useful. If you find useful, please share to your friends. Thank you for watching.